Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The molecule is a 1,2-dichlorocyclohexane in chair conformation. Carbon A, left, bears a Cl that points downward, axial, going into the ring plane from above, shown by the downward arrow, meaning it is in the axial down position. Carbon B, right, bears a Cl shown by an arrow pointing upper right, equatorial or axial up position. Moving on to the next step. Carbon A is a stereocenter. Its 4 substituents are Cl, H, the other hydrogen, and 2 ring carbons, one going to carbon B, one going the other way around the ring. In the chair, the Cl at carbon A is axial and pointing downward. Priority order, Cl, highest, number 1, the ring carbon connected to carbon B carrying Cl, number 2 since that branch has Cl substituent, the other ring carbon, number 3, H, number 4 lowest. With Cl axial down at carbon A, arranging 1 to 3 with H, number 4, pointing axially upward, away from viewer in this orientation, the rotation 1 to 3 is clockwise. Since H points away, clockwise is equal to R. So carbon A is equal to R. Moving on to the next step. Carbon B is a stereocenter. Its Cl is shown pointing upper right, axial up position in the chair. Substituents, Cl, number 1 highest priority, ring carbon toward carbon A with Cl, number 2, other ring carbon, number 3, H, number 4. H at carbon B is axial down, pointing downward, away from viewer. With H pointing away, the sequence 1 to 3 is clockwise is equal to R. So carbon B is equal to R. And for the final step, this gives A is equal to R, B is equal to R, which corresponds to answer choice A. Option B, A is equal to R, B is equal to S would require B's rotation to be counterclockwise with H pointing away, which it is not. Options C and D assign S to carbon A, which contradicts the clockwise rotation determined above. Therefore, the correct answer is A. Therefore, the correct answer is option A.